Welcome to our second help video over the Unit 5 test. And on this one, we will pick up with question number 9. And we're supposed to replace the elements in order of increasing ionization energy. The lowest ionization energy first, highest last. Ionization energy, if you remember, is the energy that is needed to remove an electron from an atom. Smaller atoms have their electrons more close to the force that's holding them there. That's the force of the nucleus. So smaller atoms tend to be more difficult to strip. So let's look at our list here. Our list has phosphorus, magnesium, chlorine, strontium, and barium. Well, lowest ionization energy would be the largest atom. The highest ionization energy would tend to be the smaller atoms. So on this list of phosphorus, magnesium, chlorine, strontium, and barium, who is the largest atom? Remember, size increases top to bottom. Size decreases left to right. So the smallest ones are in the upper right-hand corner. The largest ones would be in the lower left-hand corner. So on our list, barium's the largest, so it should be first. So we look at our answers. Only one of our answers has barium first. So the only possible answer here would be letter A. But let's be sure it's right. Remember, the atom, they get larger top to bottom. So here's barium. Also on the list is strontium. Strontium's right above barium, so it would be second largest. Magnesium's up here, also in the same family. It would be third largest, same family or group. Now, what happened when we went left to right? The atoms get smaller. Why? Because as we go left to right, we're adding protons to the nucleus. We're not adding levels. You add levels when you go top to bottom. So left to right, they get smaller because you're adding protons to the nucleus, meaning you have more protons pulling on the electrons. They can pull them in more closely. So as we go left to right from magnesium, phosphorus is the next one in the row on the list. And then chlorine's all the way over here. So phosphorus would be the second smallest. Chlorine would be the tiniest of all of those. Therefore, chlorine would be the hardest to strip. Letter A. When we're looking at their ionization energies, we can see them right here. Chlorine's 1250. Barium was 500. Lowest. Strontium 550. Second lowest. Magnesium 730. Third. Then we slide over here. Phosphorus is 1060. Chlorine's 1250. So we know our list is in the correct order. Now we've got two dot diagrams here. We're supposed to assume they're in the same period. And we're also told they're in the main block. So that means they must be in the S or the P block. So diagram X here has one dot. That must be S1. This is the S side, P side, P side, P side. So this one has one in the S. It's an S1. If it has one electron, it means it is in the first group, group 1, family Roman 1. That diagram would have to be helium, hydrogen, lithium, sodium, potassium, rubidium, somebody in that list, cesium. We look at our next one. Here is diagram on Y. There's 1, 2, 3, 4, 5, 6 electrons on it. So it's group 16. It's in the main block. That would be Roman 6. Who's group 16 Roman 6? That could be oxygen, sulfur, selenium, tellurium, one of those. How do I know that? Because there's 6 dots. Everybody in that main block, the only main block that has 6 dots is the oxygen family. There's 2 in the S side, 4 in the P side. And we know that they're in the same period. So Y is to the right of the X. So question 10, X would be smaller than Y. No. X and Y are in the same row. Y is all the way over in group 16, Roman 6. X is all the way on the left side. They get smaller left to right. So X has to be bigger than Y. X is bigger than Y. So 10's false. Diagram X would have a lower ionization energy. Well, we just realized in question 10 that X is bigger than Y. They're in the same row. They get smaller left to right. So X is the bigger one. Y is the smaller one. X would be easier to strip Yes, it would have a lower ionization energy. 11 is true. In 12, in general, diagram Y forms cations more easily than X. Well, we just said X is easier to strip. If we rip this electron off and make X plus 1, it would be easier to remove that electron. These are harder to strip. It's smaller. These electrons are closer to the nucleus. They would be harder to pull off. In fact, X would readily form anions. In fact, our Y would normally form anions. Why would Y form anions? It only needs 2 electrons to satisfy the octet rule. So Y would likely want to be 2 minus. X would love to lose that electron, which would remove that level, that outer level, leaving the inner level full. And that's, of course, assuming that X is not hydrogen. So Y would better form anions. It would be hard to strip. It's not going to form cations. So that's false. 13, X would be the metal. Well, we know X is bigger than Y. We know that X is in family 1. Family 1 has all metals in it, with the exception of hydrogen. X and Y, if you remember, were told to be in the same period. So there's no way X could be hydrogen, because in hydrogen's period or level, the only other element there would be over here. Here's hydrogen. The only element on this end is helium. Helium would be right over here. And helium would only have 2 dots. This one has 6 dots, so X can't be on the first level of the table. So what does that mean? Well, X is in this first group. It has 1 valence electron, so it could be lithium, sodium, potassium, rubidium, cesium, or francium. Metals are on the left side of the table. Those are all metals. That's the alkali metal family. 13 is true. All right, which of these pairs is not smaller one first, larger one second? Ca2 plus and C. Is Ca2 plus smaller than Ca? Well, if you remember up here, we had talked about size. Ca2 plus would be considerably smaller than Ca, because every time we move electrons, the protons are having fewer electrons to pull in, which allows them to pull them in more tightly. A neutral atom is always larger than its positive ion or cation. Is nitrogen smaller than bismuth? If you look at the periodic table, there's nitrogen, there's bismuth. Nitrogen is way smaller than bismuth. In fact, nitrogen is only a 2-story building. Nitrogen's on the second row of the periodic table. There's the 2, it's on the second row. It only has 2 stories in its building. Bismuth is way down here on row 6. Bismuth is a 6-story building. It is much larger than nitrogen. So, yep, that's smaller. What about arsenic and potassium? Arsenic and potassium. Here's arsenic. Here's potassium. They're on the same level. What happens to the size as we go left to right? They get smaller. So arsenic is smaller than potassium. How much smaller? It would be considerably smaller. Here's arsenic. It's 120 picometers. There's potassium, 227. That's almost twice as big. All right. What about aluminum and fluorine? Let's find those. The smaller one's supposed to go first. Here's aluminum. Here's fluorine. First of all, fluorine is to the right. What happens as they go left to right? They get smaller. What happens? Aluminum is on the row below fluorine. So aluminum has 3-story building. Fluorine has a 2-story building. So by rows, fluorine should be smaller. And fluorine's way to the right of aluminum. It's going to be a lot smaller. Let's take a look. Fluorine should be the first on that list. Fluorine is only 72 picometers. Aluminum, 143. Aluminum's over twice as big. So this is out of order. Fluorine should be first on the list. Chlorine and rubidium. Let's take a look at chlorine and rubidium to make sure we have these right. Here's chlorine. Where's rubidium? Way down here, 2 rows below it. Left to right, they get smaller. So if chlorine and rubidium were on the same row, chlorine would be smaller. But chlorine's also 2 rows above rubidium. So not only is it to the right, but it's 2 rows up. Chlorine is way smaller than rubidium. Chlorine is 99 picometers, rubidium 248. That's like 2.5 times bigger. So chlorine should be first, rubidium second. What about O and O2 minus? Well, what happens when we add electrons to an atom? When we add electrons to an atom, the protons are now trying to pull in more electrons, so they have trouble. Those electrons are negative, so electrons are, as we add electrons, those negative electrons repel each other. An anion is going to be bigger than the neutral atom, the same way that a cation is smaller. So O2 minus is going to be bigger than O. The answer is D. On 15, we're looking for the lower ionization energy first, higher second. It's important to remember that ionization energy is larger for smaller atoms. So really what we're looking for here is the larger atom first, because they're easier to pull electrons off, and the smaller atom second. Smaller atom needs to be second. In general, that's how it will work. So when they're asking for ionization energy, so larger ones first. So on letter A, is aluminum larger than Al3+? We've been talking a lot about this. As we remove electrons from an atom to form cations, they get smaller because we have the protons pulling on fewer electrons. So aluminum's larger. So the ionization energy here for aluminum would be smaller. The bigger you are, the easier it is to steal electrons. If we look on ionization energies, you would have to look up Al3+'s ionization energy. That would be the third ionization energy. It is really, really a high ionization energy. Rubidium and tin. Where do we find rubidium and tin? If we look on a given low, here's rubidium and here's tin. As we go left to right, what happens to the size of the atom? Left to right, it gets smaller. So rubidium's bigger, it needs to be first. In fact, its ionization energy is 400. Tin is 700, almost double. So who should be first? Rubidium. Now we've got lead and germanium. Lead and germanium. We've got to go to the periodic table and find out where they are. Here's lead, here's germanium. What happens to the size top to bottom? They get bigger. Lead is bigger than germanium, so lead should have a lower ionization energy than germanium, because the bigger it is, the easier it is to remove electrons from. Lead's ionization energy 710, germanium 780. Germanium has a higher ionization energy. What about beryllium and potassium? Let's find beryllium and potassium. Here's beryllium, here's potassium. If beryllium was in the same row as potassium, in other words, right here, left to right, they get smaller. So left to right, beryllium should have a higher ionization energy than potassium. Not only that, beryllium's way above potassium. Beryllium's up here. What happens to the size as we go top to bottom? They get bigger. So beryllium's to the right and above. So beryllium is a lot smaller than potassium. Look at beryllium's ionization energy, 900. Potassium, 420. Beryllium takes twice the energy to remove electron than potassium. Potassium should be first. They have beryllium first. They're not in the right order. What about silicon and neon? Silicon is to the left of neon. Neon would be right over here. So silicon would be bigger than neon. Not only that, neon's a row above it. So even if silicon was right beneath neon, it should be bigger than neon. So what happens here? As we go left to right, they get smaller. So silicon's bigger than neon. It's the row above, below it. Silicon's bigger than neon. Silicon should have a lower ionization energy than neon. Silicon should be first, and it is. The answer is D. We'll pick up with question 16 on our next video.